Hi OSLO users, this is a tutorial example using OSLO's ray aiming modes. So what this is going to do is this is going to be the last video in the series on ray aiming modes that we're doing at the moment. The goal here is to provide a further example showing some ray aiming modes and actions. The instructions for this example can actually be found in the OSLO help in the program. And what you do is search on contents for ray aiming. I'll show that in just a moment. There are actually two examples at the end of that help page. We're doing the first of two. It specifically shows a lens that's meant to be used in the wide angle ray aiming mode. So if we go to our program here, if we go to OSLO, I open up the help. It's a little bit off the screen there. And I go to ray aiming. You can come down here to ray aiming modes. And this is the page that had all the different ray aiming modes defined in it. And there's a couple examples at the end. So we're going to just do the first example here. If you want to know the instructions, I'm just going to go through each of the pages here, but I'm not going to even talk about them. I'm just showing them here in the video for a moment. Steps 1 through 4. Steps 5 through 8. Steps 9 and 10, and step 11. When you take a look at this, I stopped it in case you wanted to screenshot or somehow capture that data, or if you want to just open it up inside of the help. Any of those options are just fine. I'm now actually just going to go ahead and go through the example. So let's go here to open the existing file, and I'm going to open up the and this is under OSLO's public directory, and then the light folder, and it's the Nikon fisheye lens. I don't particularly like the draw on. In this particular case, we're just going to go ahead and go here to draw the lens. So here is a picture of this lens. It's got an extremely wide field of view, a field angle. As you can see, it says it's 45 degrees, but the rays that we're actually tracing exceed that. You can look under the setup. The notes for this, and it describes why warm is needed. This is an extremely wide angle lens, and that's the general reason why. The first 4 steps, the first one is to open the lens. The next one is to change this to 85 degrees. So we change this to 85 degrees here. Then we go to the lens drawing conditions. So under lens drawing conditions, or UOCDRL, and here we're going to turn the aperture stop on. So then if we update this, it will actually draw the aperture stop now for us. It actually also drew less field points when we just changed that. Actually, it's drawing the same number of field points. It's just going out to 85 is making it not possible for some of the really wide ones to be seen, and actually it's probably good to go back to the lens drawing conditions just to show you how this one is set up. Notice it's drawing at 2 times the defined maximum field of view of 45 for the half field of view, so that's 90 degrees, and 2.4. This system has, I believe it's out to something like 108 degree half field of view is what it can actually cover. So this is just how this lens happens to be set up. It's a little bit unusual. We're setting it up to a field angle of 85 because we are going to use a slider here simply to show how the pupil is being filled. So you can see in this case the pupil is being filled at the field of view and also on axis. The last thing is it tells you to open the general to make sure it's set up for wide angle mode. So we're going to show what's going on when we use a slider if we change the field of view and only look at one field point at a time. So the slider that we're going to use is under demos. So tools, demos, and ray bundles. It asks us, these are all in the instructions, it asks us to draw just 5 rays and to do it for this maximum fractional object height in Y. So we do this. Now the unfortunate thing about this is every time I'm going to do this, I'm going to have to open this up a little bit more. So this is for the wide angle mode. If we were to change the angle, you can see the lens pupil here, the stop, I should say, the stop is filled the entire time. The rays are being aimed in such a way to make sure that, in this case, the spacings and the pupil are the spacings are correct for the calculations, and that the pupil, the stop, is being completely filled. So it's doing Hamiltonian ray tracing. In this case, it's doing an iterative process to make sure that the stop is being filled correctly. And it has to do that because this system has an absolutely enormous amount of pupil aberration. Okay, great. Now, the next thing we're going to do is we're going to go back to general. This is UOCGEN is another way to get to it. And we're just going to go up one at a time. We're going to show the rim reference, central reference, and entrance pupil. So we go to rim. When we go here to update the window, I just double-clicked here. You can also update with new parameters. You can also go, and this is what it suggested you to go to the lens draw there. You do it anyway. Unfortunately, each time I do this, I'm going to have to scale it bigger. I'm just going to do it like this. We can even go in a little bit further if we want. And now we're going to do the same thing we did before. You can see the pupil is being filled. Now what's a little bit harder to see here is that the rim mode, making sure that the ones out at the edges are correct, as well as in the chief ray in the middle, the principal ray in the middle for all field points, is actually correct. Well, it doesn't show that all the other rays can actually have their spacings changed. So you really do need wide angle mode in this. It would be a little bit misleading to think that the rim reference mode would work in this particular case if you look at it in more detail, but you can still see it being filled correctly in terms of the edges. So the next thing we're going to do is we're going to go up to the next one. So that's the rim mode. Now we're doing central reference ray. This is the one that will make sure that the, so again, I update the window here, make it a little bit bigger. And this is the one that is going to make sure that the pupil is that the stop is, the rays are being traced so that the central ray and the bundle, the principal ray, is going through this stop location. So it's not allowing the shifting of the apparent stop location from the rays in the front to be going up and down the axis. That's what happens with the last one. But this one does not get the rays out to the edge quite correctly done, and we can see that here. What I've been changing down here, by the way, is the field of view. So as I change the field of view, whoa, look at that. The bundles get a lot smaller. What this means is the pupil aberration here is such that the predicted ray bundle that's needed off axis needs to be a lot bigger than what the program thinks it's going to be in this particular ray aiming mode, and so the bundle ends up being too small. You can see here as it swings in and out, we can compare to our original down below with the wide angle mode, and you can see the bundle here is thinner than it is. It's thinner than it is here with the wide angle mode on, and therefore the pupil is being quite underfilled. So this is what the more advanced ray aiming modes are doing beyond the default central reference ray. Clearly this isn't working. It's very obvious and easy to see in this particular case. Now the last one is the first order entrance pupil mode for ray tracing. So we go back to general here. We now go to the entrance pupil. Update this window. Again, the axial beam, it looks all right. But it's when we start going out in the field of view, whoops, sorry about that. Let's do this again. Stretch this out. Now, as you can see, I've kind of lost it a little bit. If I hold control and use my scroll wheel, it can zoom it back out automatically without as many clicks and things. So now here we zoom in a little bit here on the pupil. And this one, what happens is as I shift, the beam is going to get narrower, but notice it's actually also walking. This is what in the program help, it talks about how you can have a decentration at the stop of the beam that is happening because when the principal ray and at the full field of view, the chief ray, often it's generically called the chief ray, what's happening is it's crossing the axis at different locations, so the beam is offset. So this one's actually harder to see what's going on when you're in that close. So we're going to go out quite a ways here. Again, our stop is in between these two doublets. So when we do this, you can see what starts happening is the actual stop location that the bundle thinks there is in this case is clearly not in this location. In this case, it's quite behind the lens here. If we go to the other side a little bit, it would end up being also behind. So as you can see, as we're shifting around here, the apparent stop is shifting back and forth. So the central reference ray mode makes sure that is correct, but this first order entrance pupil mode doesn't even do that. And so it's not just that the bundle isn't wide enough due to the pupil aberration, but the spherical aberration of the pupil and the fact that it can shift up and down the axis is also a factor. This is a great little demo just using sliders that shows you, as you change the field of view, what happens to the bundles in each of the cases. Again, this is a lens. This is the Nikon fisheye lens example that has an extremely wide field of view. So it's being chosen because you must use wide angle ray aiming for it. Thanks.